Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own mass coder this side with another lecture of binary tree. Now the problem is check if all leaves are at the same level. Check if all leaves are at the same level. The problem is actually very simple, right? The question is actually the heading is actually telling you what does it mean. So all leaves. What do I mean by leaf? The leaf node is a one which doesn't have a right child, which doesn't have a left child. The right child and the left child are both null. Then this node is known as leaf. So in the given tree, which nodes are the leaves? So I can say this node is a leaf node, this node is a leaf node, this node is a leaf node. These three nodes are my leaf node. Rest two are not my leaf node, right? Now, if I see the levels, what are the levels? The horizontal levels, which we discuss in the level order traversal. So this is my level 1, this is my level 2, this is my level 3, and these are my leaf nodes. Am I right? Okay. So if I see one leaf is present at level 2 and two leaves are present at level 3, in this case I will be returning false. In this case I will be returning false. But if the tree looks something like this, 1 with 2 with 3 with 4, 5 and a 6 here or anything else, right? So that the leaves are at same level, that is this level 1, this is level 2 and this is level 3. But the thing that changed here is this is a leaf node, this is a leaf node, this is a leaf node, and 3 is not a leaf node now. So you can see all the leaves are lying at level 3. So my answer will be true in this case. My answer will be true in this case, right? Okay, so this is the only thing you have to do. If the all leaves are at same level, return true. If any one leaf is also not at same level, return false, right? Okay, now how will you solve it? How will you solve it? Again, the itinerary we are following. First case, check the question belongs to the binary tree. So first thing you should see is traversal. Can I use any kind of traversal technique over this question to get my answer correctly? Yes, there is someone. So level gives you a clear indication of level order traversal. Level order traversal. Use that trick into your observation. Use that trick into your observation. What can you do? So we know about the level order traversal. If I trick this tree and try to find out the level order traversal of this tree, it will look something like 1, 2, 3, 4, 5. But that doesn't give me a clear indication, right? But that doesn't give me a clear indication. Now go to the algorithm we were studying in the level order traversal. Go to the algorithm. What was the algorithm? We used a queue. We used a queue. Suppose this is my queue. What did we do? We first pushed in the node 1. We pushed in node 1, right? Then we popped it out, pushed 2 and 3. Then for 2 iterations we popped 2, we pushed 4, 5, we popped out 3 because 3 doesn't have a child, so we did not push anything. Then 4, then 5. Now let me stop you at some points in the algorithm. Let me stop you at some points in the algorithm. First of all, my tree is 1, 2, 3, 4, 5. Now if I try to write down the queue again, this is my queue, suppose, right? Along with the queue I will maintain a pointer, let us say level, which is currently -1, which is currently -1, right? Okay, let us say level is currently 0, level is currently 0 and my leaf is -1, leaf is -1. Okay, now what will I do? I will push the node. I push the node 1. Before pushing the node, sorry, okay, just push the node. Okay, now pop it out. You popped out node 1. Check if it is a leaf. Check if it is a leaf. How will you check if it is a leaf? So you will say if node right and node left both are null. So for null you will just put an exclamation mark before that is a not sign. If both of them are null, then what will happen? There are two cases. The leaf can be -1. That is, you have not encountered your first leaf. Leaf is actually saying what is the first level. What is the level of the first leaf you encounter? Leaf is actually saying level of first leaf you encountered. You encountered. Right? That is easy to see. That is easy to see. So if both node right and node left are null, two cases. If leaf equals to -1, in that case assign this level to the leaf. So leaf equals to the current level. For the node, for the root, it is equals to 0. I say that this is level 0, this is level 1, this is level 2, right? Okay, you popped out 1. For popped out 1 you will write 2 and 3. The algorithm remains same. 2 and 3 are written here. You incremented your level because the first level is clear, so you incremented your level. So level plus plus, level plus plus, which will give me a level of 1. Now for first level, 2 and 3 will be popped out. That is 2 iterations it will require. It will pop out 2, it will write 4 and 5. You can see 2 is not a leaf node, so this if condition will not be used, right? Okay, moving on. When we pop out 3, we see that this condition is activated again. This condition is activated, right? Currently my leaf is -1. Currently my leaf is -1 because root was not null, right? Root was not a leaf node. So my leaf is activated and I will set my leaf node to the current level, which is 1. You can see the 1 is also here, 1 is also here. So leaf will now become equals to 1. Pop out 3, nothing can be added for 3 because 3 doesn't have a left or a right. Moving on, I will pop out 4. I will pop out 4. Okay, if I pop out 4, is 4 a leaf node? You can see it doesn't have a left, it doesn't have a right. Yes, it is a leaf node. But the current level is 2 because after popping out 3, the level was finished and I got to level 2, which is my current level. Leaf is also not -1. So my second condition is if leaf is not equals to -1, assign it. Else if leaf is not equals to level, that is the first leaf was encountered at level 1 but the next leaf is encountered at level 2, the levels does not match, straight away return false. That for the given tree the leaves are not at the same level because 4 is at level 2 and the first encountered leaf which was at this level was at level 1 because the leaf is saying level 1. You can see 1 here and you will return false. But if the whole algorithm runs without any problem, then you can return true, right? If it is not returning false anywhere in the code, you can simply return true. So what is my code gonna look like? Simple level order traversal. Use a queue, right, of tree node star. Okay, use a level which will be initialized with your, it is your will, you can initialize with 0, you can initialize with 1, the code will, the algorithm will remain same. Let us say you are initializing with 0 only and leaf equals to -1. Now what will you do? While my queue is not empty, that was we were doing, right? N equals to q dot size for current level, right? Now for I equals to 0 up till n, first you popped out the node, so node equals to q dot pop, right? That is q dot front, q dot pop. That two operations are merged into one, right? Now check if node doesn't have a right child and a left child. Use an and condition, right? Node right. Then that means it is a leaf. Now two conditions that can arise is if leaf equals to -1. That is, this is the first leaf node you encounter. In that case, leaf equals to level, the current level. Otherwise, what will you do? Else if my leaf is not equals to my current level, that means I have encountered a leaf but that was a different level, that was a previous level, return false. Return false, right? This is for the if condition. Otherwise, move accordingly. What will you do? If node left, then push it into the queue. So q dot push node left, and similarly for the right part, similarly for the this part for the right as well, right? After this for loop of size n from 0 to n which was working, I will have to increment my level because I just finished popping and pushing out the current level, the initial level. So I will say level plus plus and you can end the loop. If the whole level order traversal runs fine, the whole level order traversal runs fine, then you can just say return. What do we return? We return true because we did not encounter any case of false. That means the all leaves are at same level. This is your code. So what did we do? We just use a traversal technique. We just use level order traversal with some modification to encounter our answer. That is what I am saying from the first video itself. Whenever you are encountering a binary tree, 99% of the time traversal will solve it, right? Only few questions are there which are actually requiring you to go into the process without traversals, right? Okay. Now, my question to you is, which I will be answering in a short interval in the next video, that can you solve it without using level order, right? You can use any traversal you want, but I want you to solve without level order. You can use pre-order, you can use post-order, you can use in-order, right? This is my question to you, which I will be discussing in the very next video. So please stay tuned and bring me with the answer. The best answer in the comment section of this video will get a shout out in the next video. Okay, so it is time for us to see the code now. That's what you were waiting for, right? Okay. Alright guys, so you can see the coding section here. But before starting with the code, I would like to request you to please subscribe to my channel if you are new here, because it really motivates me. And now it is time for us to go full-fledged into the code. Okay, so first thing, I will initialize the parameters I want. Int level equals to 0, leaf equals to -1, right? Then I will need a queue. So queue of root, queue of node star types. I will maintain a queue. Now what will happen? I will just try the traversal, that is while my queue is not empty. Oh, I have to push the root also, right? Sorry. If my root is not null, then queue dot push the root, right? If my queue is empty, sorry, while my queue is not empty, what will you do? You will first get the size, that is int n equals to queue dot size. Now what will you do? For int I going from 0 up till ni plus plus, what will you do? You will first get the node. So node star node equals to q dot front and then pop that element out. Q dot pop. Now what will you do? You will say if my node left and my node right both are null. In that case, what will you do? Two cases can arise. If my leaf equals to -1, that is I have not encountered the first leaf node, set your leaf at the current level. Otherwise, else if my leaf is not equals to my current level, in that case return false straight away. Return false because I encountered two leaves which are at different levels, right? Otherwise, in the this is the if condition. Otherwise, if the normal level order, if node left is present, q dot push node left, q dot push node left, and similarly if node right is present, q dot push node right, right? Okay, after the current level, that is after push popping out the n nodes which were at the current level, you will just increment your level plus plus to mark the different level. And at last, if the whole traversal works without returning false, that means our answer is going to return true. Let us try to compile and run it. Hope it will work fine, should not give any error. It is running fine for the sample test case. Let us try it for the hidden test cases as well. Working fine and running. Alright, so it is running fine, and hope you liked the video. Hope you were able to understand the concept, and thank you for watching. That is all from my side. We'll meet again tomorrow, and please bring me the answer of the other traversal technique. Comment down the answer or you can DM me also. Okay, thank you. Have a nice day.